learn about a project titled Forensic Detection and Classification using the advanced deep learning. Forensic science places significant emphasis on detection and classification, and recent years have been a surge in prominence of sophisticated deep learning methods in these domains. The integration of the deep learning into forensic investigation has revolutionized the evidence analysis, yielding outcomes marked by the highlighted precision and efficiency. Through the utilization of artificial neural networks, deep learning facilities, the automated extraction of intricate patterns, and the features from the diverse forensic data types like images, sequences, unlike the traditional manual examination approaches that are time consuming and subject to human bias. Advanced deep learning algorithms offer the automation and highlighting the accuracy in the forensic analysis, thus expediting and enhancing the reliability. This study delves into the realm of applying the cutting-edge deep learning technique to the forensic detection and the classification, aiming to eliminate both the potential advantages and the challenges that is captivating the field presents. And the primary objective of this project encompasses the several key aspects. Firstly, it aims to conduct an in-depth exploration of state-of-art deep learning technique, and it will offer a comprehensive overview of cutting-edge algorithms including CNN, ResNet 50 and transformer-based models, analyzing their relevance to tasks related to forensic detection and classification. Additionally, this study seeks to delve into the diverse landscape of forensic type. This involves investigating how the deep learning technique be applied to the various forms of encompassing the digital images, clips, and the research also entails a rigorous evaluation of the performance metric of the deep learning model. By comparing the accuracy, precision, recall, and open score against the conventional forensic method, this project will underscore the potential enhancement in both the efficiency and reliability. Importantly, this study is committed to addressing the obstacles and constraints associated with the integration of advanced deep learning into the forensic analysis. Challenges like limited data availability, interpretability, and ethical considerations will be identified and discussed. It will propose the direction for forthcoming studies and the potential advancements in deploying the deep learning with the realm of forensic science. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. This step involves importing the essential libraries and packages such as TensorFlow, PyTorch, OpenCV, and the other relevant tools for the deep learning, image processing, and the data manipulation. And the second step is exploring the dataset. The dataset containing the forensic data of images, and these exploration provide the insights into the nature of the data before processing. And the third step is image processing. The techniques are applied to enhance the quality of the input data. It encompasses of resizing, normalization, noise reduction to prepare the images for the analysis. And the next step is loading the pre-trained model. The pre-trained deep learning model is loaded. These models have been trained on large data set for the specific task and can be fine-tuned, use it directly for the forensic detection. And the next step is data augmentation. Data augmentation techniques like rotation, flipping, and the color adjustments are employed to diversify the data set. And the next step is processing the data set based on the YOLO v5 model. Chosen models such as YOLO v5 process the pre-processed data for the detection and the classification. And the next step is building the model. Here various models are built. First one is YOLO v5. It stands for You Only Look Once version 5. It is an advanced object detection model that excels in real-time identification of objects and images. Its speed and accuracy make it suitable for swiftly detecting the forensic objects or features, enhancing the efficiency of investigation and evidence analysis. And the next one is faster RCNN. It stands for Region-Based Convolutional Neural Network, is adept at identifying the region of interest and extracting the features. This model ability to precisely locate and classify the forensic object within the images is valuable. It captured the intricate pattern and nuances crucial for effective analysis. And the next one is CNN. CNN stands for Convolutional Neural Network, is an automatic feature extraction from the images. Tailoring a CNN for the forensic data enable it to identify the relevant frames or objects, contributing the more accurate detection and the classification in the forensic analysis. And the next one is ResNet 50. It stands for Residual Network 50, a deep architecture is beneficial for handling the complex features and the forensic data. Its transfer learning potential allows the fine-tuning on the forensic data, enhancing its precision and adaptability for detecting and classifying the specific objects or pattern in the forensic investigation. And the next step is the user gives input as image. Here we build a Flash as a web interface where the user can provide the input image to it. And the next step is the given input is pre-processed. The input image undergoes pre-processing similar to the training data. This ensures that the input image is the suitable format for the model. And the next step is train model is used for the prediction. The pre-processed input image is fed into the train detection model for the inference. This model identifies and localizes the object or the features relevant to the forensic analysis. And the last one is final outcome is displayed. The processed image with identified object or features is displayed to the user, and this outcome overrides the insight into the forensic analysis. And the execution of the project, to execute the project first we need to open the code folder. And this is the code folder containing of various files within it. The data RCNN folder containing of images that will be used to the project, and the sample folder containing of the folders which containing of various images that will be used to test the performance of the model. And the static folder containing of the images, JavaScript, CSS files within it. And the template folder containing of typical HTML documents, it include of home and text result sign-in sign-up features within it. And the YOLO folder containing of the training validating images data within it. And the app is an PY file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the dataset folder containing of the CSV file. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. After this we need to write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address. And we need to copy this default address and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to this page containing of some information and the title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password and need to be entered, and then click on the sign in button. Here it will redirect it to this page containing of the choose file and upload buttons. Then click on the choose file button here containing of various images. We need to select one image and then click on the open button and then click on the upload button. Here it predicted the uploaded image is of real one. And by using the try again button, we redirect back to this index page containing of choose file and upload buttons, and then click on the choose file button and select the another image, and then click on open button and then click on upload button. Here the uploaded image is detected as of forgery one. In this way, we can detect the forgery or the real images by using the various deep learning algorithms. And in conclusion, this project has demonstrated the significant potential of advanced deep learning technique and the field of forensic detection and the classification. By leveraging the power of artificial neural network, deep learning models have shown the promising result in automatic and enhancing the various forensic analysis and leading to the more accurate and efficient investigation. The review of state-of-art deep learning algorithms revealed their effectiveness in processing and extracting the complex pattern from the different type of forensic data, ranging from the fingerprint to the digital images. Moreover, the performance evaluation of these models indicated the superior accuracy and the reliability compared to the traditional manual methods.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.